All right, so far we've simplified our rational expressions, we added, we subtracted, multiplied, divide, and then today we're going to be solving, so they're going to look like equations. We're going to start off with an easy one in lesson 11.8, and it's just going to be a proportion. And we know that with proportions, we can use cross multiplication. We can say x times the quantity x minus 4, and 3 times 4. And once we get that, we're going to multiply. Looks like when we get to this step, we're going to move everything to one side of the equal sign so that we can factor in order to solve. So we ask ourselves what multiplies to negative 12 and what adds to negative 4. And once it's factored, we can use our zero product property to find out that x is going to be equal to 6 or negative 2. Then we need to check for extraneous solutions because we want to make sure that both answers work in the above equation. So on the left-hand side, I subbed in a 6 everywhere I saw an x, and I got 2 equals 2, so that one worked. And then over on the right, I subbed in my negative 2 everywhere I saw an x, and I get negative 2/3 equals 4 over negative 6, which is the same as negative 2/3. So there are no extraneous answers here. So we're going to look at one that's just a little bit more complicated. So sometimes we have to find the least common denominator. And I'm going to show you how this compares to an addition problem because they are very similar but yet different. Okay, on the bottom of the slide, I have a plain old addition problem where we had to find our least common denominator, which was 3x. So I had to multiply the numerator and the denominator of the second fraction by x over x, right? That gets us here, and then we add. Our denominator just carries over, it doesn't combine, and sometimes we're able to factor and reduce. How that is different from the top is here we have an equal sign. So we still have to find our least common denominator, and in this case it's going to be x minus 7, x minus 2. That would multiply to a positive 14 and add to a negative 9. And I'm just going to get rid of this for a second. Okay, so now we're going to multiply every piece of this by x minus 7, x minus 2. So x minus 7, x minus 2, but not the denominator. Notice down here at the bottom it's the numerator and denominator. Here we're multiplying by the entire LCD, and it's only in the numerator, or over 1 if you want to do that. So then this one's going to be x minus 7, x minus 2, and then we multiply this side by x minus 7, x minus 2. And this is important to do this because we get rid of the denominators. So we get rid of that. So we have 3 times x minus 2. Then we have plus 1, and that's multiplied by this entire piece, and we're going to bring that down. And then when we get to the 8, the denominator all cancels out, so we're just left with an 8. So we'll clean this up a little bit, and I'll show you a better example. So this is just a cleaned up example of what I had. You'll notice here's my LCD. We multiplied each rational expression by the x minus 2, x minus 7, and then we did our canceling. And again, I already showed you this, but this is just a little bit neater. So now on the next slide, we're going to condense everything, put all our expressions on one side, and then factor to solve. And at any point, remember to pause the video and maybe write down this example so you have something to go by. Okay, so this is what we have after our x minus 7's canceled out, and in some cases our x minus 2. We're going to multiply everything. Now we're going to combine our like terms, get all our terms on one side. We're going to factor out an x, and then we're going to use our zero product property to find out that x equals 0 and x equals 6. And then again, we can put these back into the original problem to make sure we don't have an extraneous solution.